Welcome back to Katha by SHRADDHA'S Science Stories. Today, we are going to look into one of nature's most stunning, most beautiful phenomena. Which do you think it is? It turns the sky into 1,000 smiles of color. What could it be? Yes, sunrises and sunsets. And we are going to look into why do sunrises and sunsets look the way they do? Why are the gorgeous ranges of reds and oranges in the sky when the sun rises and when it sets? But to understand that, we first need to delve into how we see color. Now, as we all know, light that appears white to us travels from the sun a very, very long distance in the form of invisible waves. Here's our Earth, and here is our sun. Not to scale, of course, the sun is much bigger than our Earth, but these are the only props I have, so let's work with that. So the sun gives out rays and they travel all the way to Earth, yeah? And they traverse a very long distance and through a lot of atmosphere to get to our Earth's surface. Now the light that we see, which appears white in color, is actually not white. It is made up of many different colors of differing wavelengths. You knew that, right? Because another natural phenomenon that we see all the time when it rains, and if you're also lucky, is a beautiful rainbow. And a rainbow is nothing but that white light being dispersed or being refracted into its several components, into its 7 major color components. We've all learned the acronym WIBGYOR, and that's exactly how we see the rainbow appear, with the lowest part of the arch, the shortest arch, being the blues, violet and indigo and blue, WIB, and then GYOR, going to green, yellow, orange and red. So the oranges and reds are the largest arc and the blues are the smallest arc in a rainbow. It's very interesting why those colors appear in that particular order. They do because of the size of the length of the wave. Now the blue colors have the shortest wavelength, whereas the reds have the longest wavelengths. And what does that really mean? What does wavelength really mean? All it means is that the blues travel from the sun to the Earth's surface in shorter waves, and therefore they have a shorter wavelength, whereas the reds and the oranges travel in longer waves, and therefore they are said to have a longer wavelength. Now, why is this even important? It is very, very important to know this because that explains why our sunrises and sunsets look red in color. Can you think why? Let me tell you. So at sunrise and sunset, the sun's rays have to travel the longest distance to reach the Earth's surface. But in the middle of the day, when the sun is right above our heads, say at noon, the rays travel the shortest distance. But at sunrise and sunset, they have to travel for much longer distances. And as they traverse those distances and enter the atmosphere, the blues, remember the ones with the shorter wavelength? They're traveling in shorter spurts, right? In shorter waves. And they get scattered much more easily than do the reds. So imagine a ray traveling through a whole amount of atmosphere, and as it enters the atmosphere, all the blues in that white light, the blues are getting scattered and diffracted and just deflected in all directions. And by the time that particular light ray reaches the Earth's surface, what's left are only the yellows and the oranges and the reds. And that is what we see as the sun rises, is only the light that's left with the longer wavelength. And that's why our sunrises and sunsets look to us as they are a beautiful painting of yellows and reds and oranges, because all the blues have already been diffracted away. Isn't that interesting? And that is the science behind one of my favorite views of the sky, the sunrise and the sunset, when the sky smiles in 1,000 colors, but mostly reds and oranges. I hope you liked the science story, and see you soon with more. Bye.